All right. Thanks for tuning in, everybody. We're going to take a look at types of waste and landfills versus incinerators. So let's get started. So go ahead and read these about which of the following stats about waste is correct. So pause the video, write down what you think is the best answer choice, and the multiple mark there, MM, means that it could be more than one. All right, welcome back. Let's see how you did. So B, the largest component is paper. The largest growing component is plastic. And E, the amount landfilled each year does decrease because each year more waste gets diverted from landfills by more recycling and more composting. Here's a breakdown of municipal solid waste, and this data is more from like 2005, but paper continues to be the largest portion. And we can also see yard trimmings, which at Tahigas landfill is being mulched. Food scraps, which they have a plan for capturing at that site and composting right there to make methane and fertilizer, but right now those food scraps are getting buried in the dirt. And of course plastics generally get recycled as long as they are not going into the trash. And metals, glass, these are all recyclable materials. Rubber, leather, and textiles unfortunately have to just get landfilled. And wood gets landfilled, although you, in theory, can mulch it up as well. So you could take like 2x4s and they could also go through a mulching process. And or it can be burned as well. So let's take a look at the historical perspective, starting with 1960. We can see a couple things going on here. Number one, we can see that even though the amount that we were landfilling was increasing all the way from the 60s to the 80s, we started actually landfilling less and continue to landfill less to this day because we're diverting more of the trash to these other routes. Yellow is composting, and that's been the biggest increase over the past couple decades. And so composting meaning that you are, like what we learned before at Tahigas landfill. They're taking the food, they're mulching it. So mulching does count for composting, even though we normally associate composting with just food scraps. Okay, then you see recycling has been growing as a way of dealing with our waste. Combustion, burning it in incinerators, has also been growing. And we can look here at the total waste. We see that plastics is the one component that has increased the most. It's gone from a very, very small sliver in the 1960s, getting wider and continuing to widen. And plastics are very cheap. You can make it from crude oil, which is also very cheap in comparison to other starting materials. What else can we see here? Paper continues to grow as a portion of our waste. And yeah, you can just see generally a breakdown. If you were to look at metals, we've been producing about the same amount of metals as waste for decades. So let's take a look at landfills and incinerators. Go ahead and pause this. Which of the following is a useful byproduct of sanitary landfills? And this one is also multiple mark. All right, let's see how you did. So D is actually the only correct answer there. One of the useful things is that it does produce methane, which is called cogeneration when we use that methane to produce energy. And you might say it's a useful byproduct if you're capturing it. If it's just escaping to the environment, then it's very bad because it's a greenhouse gas. Each molecule of methane is 25 times more potent as a greenhouse gas than CO2. And these other things, I give you some comments there about the nutrient-rich leachate. With landfills, you do get leachate, which is liquids that are sort of like seeping on the bottom of the landfill. And those liquids typically contain a lot of toxins, all the cosmetics that have been thrown away, all the e-waste that's in there that's giving off heavy metals, things like cadmium and mercury and all that kind of stuff. That's happening in there. And so it's not nutrient rich, it's actually toxin rich. You have decomposed biosolids for agricultural fields. That's not a true statement. And that would make more sense to you after we've visited the wastewater treatment plant, where they do take the wastewater from flushing things down the toilet and showers and all that, or from the kitchen sinks in your homes. That ends up at the wastewater treatment plant, where they can then capture that as biosolids, decompose it, and use it as fertilizer. but we cannot do that with landfills. So also future land for commercial development, that's kind of a trick question. The only thing you can do with finished landfills is build a park. So we got Elings Park, and you cannot build homes, and you cannot build businesses or commercial buildings. All right, so let's take a look at the sanitary landfill. I had you guys label these parts in your assignment 1.3. Just want to point out some things. One of the very first things that we saw at Tahigas landfill was a little building where they were doing electricity cogeneration from methane. And that was powering, I think, 3,000 homes in the area. The idea there is you have methane, which is a very flammable gas. And when you burn it, you can convert water to steam. And that steam can then flow through turbine, which are like big fan blades. And that turns a generator, which makes electricity. And we'll demonstrate that in class. And we also saw some pipes sticking up out of the ground. And most of those were for methane recovery. So as they put it, you basically drill a hole through your landfill. You stick pipes down there like straws, and it collects the methane. We saw obviously them dumping the trash, but mostly what we saw was a bunch of dirt, because with every portion of trash you cover it with dirt. You only want a very small section being exposed at one time so that you don't have wildlife coming around. If you could go deeper into your landfill, you would see a bunch of you have a layer at the very bottom, so plastic liners are used so that any seepage of liquids doesn't go all the way down into your aquifer. This idea of aquifer is a little bit of a strange idea for many people, that there's actually water under the ground. And basically anywhere you dig on the planet, you're going to hit water if you go deep enough. And that water, we actually tap into it using wells, and that's how I get the water at my house. In my house, the water is pretty high, or pretty close to the surface. We only have to go down like 50 feet before we hit water. But you don't want those liquids leaching into your aquifer and therefore contaminating your groundwater. That's a very bad thing to happen. So what we have here is we put liners. We often will use a clay liner, and that's the color that we see here in yellow. And then above that in orange we have the plastic liner, both doing the same purpose of keeping leachate out. And the gravel, what's nice about gravel is that it has a lot of pores in between the rocks, and those pores can hold the liquid, and then that liquid can be pumped up through these leachate collection pipes. And from there it can be analyzed to see if there's anything really nasty in the water, like really bad heavy metals or something. But you can also treat that leachate. You can let it sit for a little bit where the liquid part of it, the water, can boil away, or not boil I should say, just evaporate away. And those solids that will be left behind, those you can then dispose of in a more contained area where it's not as dangerous for the environment. And then you have your groundwater monitoring well here, just checking to make sure that the groundwater is not getting polluted. So yeah, why do we call it a sanitary landfill? Because waste is buried or piled up so as to avoid contamination of the environment. And as we said here, the clay and plastic layers are critical to avoiding groundwater contamination from polluted leachate. Here's a park in Berkeley on the capped landfill, although I probably should have taken a picture of Elings Park, which is more local for us. What are some drawbacks of landfills? Well, one, the leachate will likely escape even from well-lined landfills. The nice thing about Tahigas landfill is that it's sitting on top of, what do they call it? I forget the name, but shale. So shale is a layer of rock, and the name for the shale up in that area, I forget the name, but it's the local name for it. And another drawback of landfill is that because you have dry conditions to try to combat leachate or minimize leachate, that means you also get very slow bacterial decomposition. And the fact that it's slow, well, the bacterial decomposition is happening without oxygen, so it's giving off methane, which is bad as a greenhouse gas, but good if you can collect it and make electricity. But the slow part of it is kind of bad, because that means you have to be collecting it for a long time. And even at Elings Park, which hasn't been used as a landfill for like 50 years, it's still giving off methane. And so you still have to go through the trouble of trying to capture it and burn it off so it doesn't go off into the environment. So they produce methane. That's the drawback, as we've discussed. And finding sites is difficult. We call it NIMBY, not in my backyard. People really don't want to be anywhere near a landfill for the reason mostly that it smells and attracts wildlife. like, I guess you could say nuisance wildlife, like seagulls. All right, so switching over to incinerators, which of the following is an advantage of incinerators? Again, multiple mark. See if you get the correct ones identified. All right, let's see how you did here. So only B was the correct answer choice. And yes, that is definitely an advantage of incinerators. You get heat from burning it, and that can be used for energy production. We call it waste to energy. When you look at A, nutrient-rich ash, well, you do get ash from incinerators, but it's not nutrient-rich. It actually has a lot of heavy metals and other contaminants. And C, less air pollution than landfills. Well, you get less methane. You basically don't get any methane being produced because you're burning it, you're not decomposing it. But you do get tons more other pollutants like particulates, which means smoke, and dioxins from burning plastics. These are like the super big muscle guys from the Story of Stuff. And methane for energy production, that's just kind of a trick question I put in there. You get methane from landfill, but you don't get it from incineration. You can burn trash to get the heat to make electricity in a similar way that you can burn methane from a landfill to get heat to make electricity. All right, so let's take a look at a picture of an incinerator. You can see here smokestacks. You can see the garbage trucks bringing the trash to it. Inside here is where the burning would be happening, but then that smoke goes through. Excuse me. A couple of devices to clean up the smoke before it goes out the smokestack. Wow. All right, so what is incineration? It's a controlled process of burning mixed solid waste at extremely high temperatures. And this can reduce the volume of the waste by 90%. Ash from burning gets landfilled. If you think about being at a forest fire, or not a forest fire, a bonfire, you can start with big pieces of wood, but what you end up with is just a little bit of ash at the end. So it's better than open air burning, which is what we used to do with our trash and what's still done in many places around the world. And it's better because you're capturing the smoke and cleaning it up a little bit before you release it. However, it can create new chemical compounds and emit toxic chemicals from the stacks. And think about the smell of burning plastic. All right, so here's a diagram that I had you label some of the parts of. So we have the truck coming in, dumping the waste. A crane comes and picks it up, drops it in a furnace, and that furnace was where it's burned, so it produces heat. And that heat goes into the boiler, and the boiler is just where you have water passing through, which turns into steam. And then that steam goes through the turbine, which is like blades, which spins a generator, and that generator makes electricity. Now the smoke from the burning process goes first through a scrubber, where it's sort of like chemically cleaned up a little bit. Looks like just water, but there's actually some chemicals dissolved in that water to have some chemical reactions occur. And this is, for example, you can help get rid of sulfur out of the smoke by chemically reacting it to make gypsum. We'll learn more about that later in the course. And then it goes to this area called the bag house, and this is kind of where you're using basically vacuums to suck up the particulates and getting them to settle to the bottom and then drop into this stream here, this little pipe where you're collecting your ash. So you think of ash, and basically what is smoke? It's like very small pieces of ash or particulates, and they're going through the system here, and then they get captured in the bag house and then dropped in. In the end, that ash goes to a landfill for disposal. And whatever makes it through goes out of your smokestack, and so you try to minimize that. Okay, so that's kind of an overview, and we'll go over it right now on your paper. I'd like you to write down whatever questions you have that you want to discuss in class, and I will be happy to discuss them with you. All right, see you then.